Hello students, welcome to KENE'S Educare, a group of KENE solutions. This is part 7 of lesson number 1, Matter in Our Surrounding. So if you all remember, in part 6 we ended up studying about the properties of gas, where we studied many things about gas, right? And now we are just left with a concept called as evaporation, which we will be completing in this part, and then in next part we will be let's see if we will be able to complete that or not. So next part will be the last part for this lesson, Matter in Our Surrounding. Okay, so as we are on the verge of ending the lesson soon, I want you all to have a, you can say, a very good revision on whatever we have studied so far in this lesson, right? So before I start with the lesson, with this part 7, I want you all to please revise whatever you have taken, whatever you have made notes on the lesson. So please revise it once, everyone. I hope everyone is revising all the notes that you have written in your book. I will be showing you the slides one by one as well. Okay, so once you are going through your notes, you'll come to know if you have missed any important points or not. Okay, so we have started this lesson by discussing about what exactly matter is and how can we classify matter on the basis of physical state and chemical composition, right? So I want you all to please go through this once. Then, as I said, that on the basis of physical state, we can classify matter as solid, liquid, and gas. And on the basis of chemical composition, we can classify it as pure substance and mixtures, where pure substance can either be an element or a compound, and mixtures can be homogeneous or heterogeneous, right? So after this classification of matter, we discussed on physical nature of matter, where we studied this physical nature of matter through an activity 1.1. So for this activity as well as for this physical nature of matter, I have given you what exactly will be the observation, explanation, and inference, right? So now instead of looking in your book, I want you all to practice this. Like the activity has been given, you know the activity very well. You need to tell yourself what will be the observation, what will be the explanation, and what will be the inference. Getting it? So this is how you have to revise it. I hope you all are going through it and you're able to explain the observation, inference, and all. So after this physical nature of matter, we discussed on the size of the particles, like how small are these particles of matter are, and we even discussed this with respect to an activity. So I want each one of you to please go through it once. So this activity is again very important. You should be knowing to write the observation, inference, and you can say explanation on it. And the kind of revision that I'm telling you, I hope you have understood it. Now everything is in front of you. You have to tell yourself, looking at this activity, like what will be the observation, what explanation will you give for this, and what inference or conclusion you can come out with, right? So this is what you need to do the revision on. Okay, and I hope you, every one of you, are doing the same. Then we discussed how particles of matter, it keeps on moving continuously. This is also a very important part. Whenever you are writing or discussing about particles, make sure you're drawing this figure with respect to solid, liquid and gas respectively, because that is how, if you can see the shaded blue part that they have shown in liquid and gases, whereas like in solids it's like negligible movement can be seen, because in solid the particles are compactly packed. That is the reason, right? Then we can explain this like particles of matter continuously move with this activity where we burn an incense stick in one corner of the room, but the fragrance, it smells all over the room, right? So this is an example that particles, they keep on moving continuously. Okay. And I have like told you in the last part as well that along with this incense stick we have like you can say perfumes and all which can be added, so you can add your own, you can say examples to it. Okay, then we discussed on this activity 1.4. So I want you all to like answer all the question marks which have been given over here. Like the first question is, what do you observe immediately after adding the ink drop? You have to answer that question. What do you observe immediately after adding a drop of honey? You need to answer this as well. And then for how many hours or days does it take for the color of ink to spread evenly throughout the water? You need to even answer this. Okay. And what conclusion you can come out with it. Then we discussed on this activity 1.5. Now you know how to do the revision. Whatever question mark that you can see on the screen, you need to answer them. Okay. After this, we discussed on that particles of matter, they attract each other, right? So this activity is like a fun activity which if you do, you will enjoy, as well as like you will understand the concept as well. Okay. So the main explanation is given over here in activity 1.7. So I want you all to please go through this activity and like whatever observation, explanation and inference that we have discussed, you need to let yourself know that. Okay. So I hope you all are going through it. After this activity 1.7, we discussed on this activity 1.8, right? So this was the easiest activity which you might have performed as well. So after this 1.8 activity, we started discussing on states of matter, where we know that matter exists in three different states, right? And these three different states of matter are solid, liquid and gases. But if you know, apart from this, like these are the three different states which have been commonly known. But apart from this, we have two more states, that is plasma and Bose-Einstein condensate. So we have bit information on both plasma and Bose-Einstein condensate, which we will be discussing further. But here, like we discussed on the properties of solid and an activity which was demonstrating all the properties of solid. We have done that as well. So I want you all to please go through the property once. So here altogether we have six different properties of solids, which include like they have definite shape and volume. The space between the particles are going to be minimum because they are compactly arranged, and the reason of getting compactly arranged is the force of attraction between the particle is maximum, because of which the movement of the particles is minimum. Okay. And like we cannot compress solid. Now when it comes to gases have a speciality, or one of the, you can say, properties of gas includes that it is highly compressible, because of which we have that oxygen, which is oxygen gas induced in the cylinder. Then we have LPG, the liquefied petroleum gas, which we use at home, the gas cylinders that we use at home. In that also a gas has been compressed. So gases are highly compressed, whereas solids, they are less compressible. We cannot compress them into a cylinder like gas. Okay. Then the rate of diffusion of solids are going to be less, and all the six properties like are been demonstrated by this activity when we take these articles. And like we have to check the shape, boundaries and volume of all the, you can say, articles which have been given. Okay. So I want you all to please go through this activity once, and then we'll move further with the properties of liquid. After this, we discussed on the properties of liquid. So I want each one of you to please go through it once. After this, we discussed on this activity 1.10, which is demonstrating all the properties of liquid. Now there were like 4 different properties of liquids which were given, and you should be knowing this, that liquids do not have their own shape. Liquid take the shape of the container in which we add them, right? So, and the space is going to be like more than solids and less than gases, and even the force of attraction between the particles are going to be less than solid but more than gas, and the movement of the particle is going to be intermediate. Got it? After this, as I said that we discussed on this activity 1.10, then we discussed on properties of gases. So here we have 6 different properties of gases which have been given, and I want each one of you to please go through it once. After this, sorry, we discussed on this activity 1.11 using this syringe and the piston, where we saw like how highly the gases can be like compressible, right? So I want you all to please go through it once. After this, we discussed in detail about the CNG and LPG that I was stating about. So I want you all to please go through it once. After this, we discussed on this like how the particles are been arranged in solid, liquid and gases. So I want you all to please go through it once. Then we discussed on like can matter change its states or not, right? So I want you all to please go through it once. Then we discussed on effect of change of temperature, as well as like if you remember in the last class we discussed on what is the effect of change of pressure, right? So I want you all to please go through it once. So here we have like the basic information on what is like melting point, boiling point, latent heat of fusion, latent heat of vaporization, right? So we have all studied them in detail, and I want you all to please go through it once. So here we have like interconversion, which has been shown how solid state can be converted to liquid state, how liquid can be converted to gaseous state. So we have that information. So I want you all to please go through it once. Then we discussed on this activity 1.13, where we have studied about sublimation in detail, like how can we separate camphor and salt solution, you can say. So we can do that by sublimation process, right? So I want you all to please go through it once. And I hope you have like drawn this figure as well, showing how exactly sublimation of ammonium chloride is taking place. But like if ammonium chloride, I know it's not available at home, even the funnel will be difficult for you to find, right? So instead of that, like if we have to you can say separate camphor and salt, we can also do that through sublimation process. Okay. So after this we discussed on like effect of change of pressure. So we have already discussed on effect of change of temperature in detail. Then we discussed on effect of change of pressure. So I want each one of you to please go through it once. So this experiment was like very important. By using the piston, we were trying to bring the particles closer, and you can see in first case, when the pressure has not been applied on piston, what is happening in that case? The particles are far away from each other, right? Then in second picture, once a bit pressure has been applied, the piston moves down and the particles, they also like get close to each other, somewhat close to each other. And lastly, in the third picture, when more pressure was applied, you can see how the particles, they got arranged together and they are like so close to each other, right? So we can conclude over here that by applying pressure, particles of matter can be brought close together. This is what conclusion we can come up with. Then we saw how exactly the interconversion of three states of matter can happen. Like if we have to convert solid to liquid, we have to perform fusion. If liquid needs to be turned to gas, here we have like process called as vaporization. When gas needs to be turned to solid again, we need deposition process which takes place over here. Okay, now in this case, like if I want to convert liquid into solid, I have to like make that solution or substance undergo solidification. If solids needs to be converted to gas, then sublimation process needs to be performed, and when gas needs to be like you can say converted to liquid, condensation process has been performed, right? So I want you all to please go through the interconversion part. Also we have some basic information on dry ice which has been given, so I want you all to please go through it once. So this interconversion table is very important. I want After this interconversion, we need to discuss about evaporation, what exactly evaporation is. For that, we have this figure which has been given where you can see the solar influx, water evaporation, radiation, heat conduction. These are few of the terms which have been used, right? So we will be discussing about evaporation today. See, do we always need to heat or change pressure for changing the states of matter? Because we just now discussed what exactly is the effect of temperature and what is the effect of, you can say, pressure, right? So, when it comes to evaporation, do you think like if you have to change the state of matter, from solid to gas, liquid to gas, gas to solid. In any case, when you are changing the state of matter, do you think that we need to always apply heat or we have to change pressure of that matter? If yes, example. If no example, you have to think on it. See, can you quote some examples from everyday life where change of states from liquid to vapor takes place without liquid reaching the boiling point? Yes, can you come up with any example where liquids are directly getting converted to vapor? And the condition over here is that liquid is not reaching the boiling point. So see, water when left uncovered slowly changes into vapor, and where like this is one of the example, if you're not covering the water on the like if you're not covering the water with a lid, in that case the water will like get slowly get converted into vapor. Then we have wet cloths, they dry up, that is also one of the example, right? So what do you think, what exactly is happening to water in about two examples? What is happening, the wet clothes, because they lose, you can say, vapor, and right, they, because of which, like if you are having your wet cloth in the morning, if you put that, it becomes dry, right? So see what is given over here, We know that particles of matter are always moving and they are never at rest. They will continuously keep on moving. We have studied that with respect to incense stick, right? So at a given temperature, in any gas, liquid or solid, there are particles with different amount of kinetic energy. So we studied that like particles, they keep on moving continuously, right? So when this is happening, when we consider any temperature, be it gas, liquid or solid, these particles are going to have different amount of kinetic energy. So if it is in case of liquid, a small fraction of particles at the surface, they are going to have higher kinetic energy. Okay, so the particles who are going to be at surface particles will have higher, you can say, higher kinetic energy, and because the kinetic energy is higher, it is going to become easier to break away from the force of attraction of other particle and get converted into vapor. Why is it happening? Because the kinetic energy is high, so it can break away the force of attraction, and if the force of attraction are broken down, the particles will get converted to vapor. Okay, so this phenomenon of change of liquid into vapor at any temperature below its boiling point is called evaporation. What is evaporation? Change of liquid into vapor at any temperature below its boiling point. So you're like, see, if the liquid is getting converted to boil, like it's been heated to its boiling temperature, then it's very, you can say, very obvious that vapors will be produced. But in evaporation, what is happening? Liquid is directly getting converted to vapor at any temperature below its boiling point. This is very important. Okay, so I just want you all to please write the points which you find important from here, and then we'll discuss the factors which affect evaporation. Now this is also very important, and you can just because you have not studied about heat conduction, radiation, solar influx and all, I'll say just ignore the figure which has been given on screen. Okay, I hope you all are writing what is evaporation. You can even write some examples and explain it in your own words. Now see, the next thing that we need to study is factors affecting evaporation. Like which are the different factors which affect evaporation. So we are going to study these factors affecting evaporation through an activity. So let's see what has been given in this activity 1.14. See, take 5 ml of water in a test tube and keep it near a window or under a fan. What we need to do? We need to take 5 ml of test tube and keep that near, like 5 ml of water in a test tube and keep that near a window or under a fan. And then take 5 ml of water in an open china dish and keep it near a window or under a fan. Take 5 ml of water in an open china dish and keep it inside a cupboard or on a shelf in your class. Okay, and then you need to record the temperature. You need to record the room temperature. What will be the room temperature? Okay. And then record the time or days taken for evaporation process in the above cases, where you will be repeating the above 3 steps of activity on rainy day as well, and you need to record your observation. What do you infer about the effect of temperature, surface area and wind velocity, that is speed, on evaporation? What do you think? See, what can you write? What observation you can write over here is surface area of the test tube is less, so less water will evaporate from the test tube. Okay, and it will take a long time for evaporation process to take place. Why evaporation is taking time? Because the surface area of the test tube is less. Then when it comes to surface area of the china dish, the surface or area of the china dish is going to be like of the two china dish that we are using, where one we are keeping it in near the window and second one we are keeping it inside the cupboard, right? So because the surface area of the china dish is same, in which we have added 5 ml of water, right? But what is the difference in both the cases? One is kept near a window or under a fan and the other one is kept inside the cupboard. So here the rate of evaporation will be faster from the china dish, which is kept in the window, near the window or under the fan. Whereas when we compare it with evaporation for china dish, which has been kept inside the cupboard, it will be very slow. So near the window, the evaporation process will be fast as compared to when we keep it inside the cupboard. Okay, and when it comes to rainy day, because like whenever it rains there will be more humidity in the atmosphere, right, as compared to other days. So evaporation is going to take longer time on rainy days, and that is why our, like you can say, wet clothes also take so much time to dry up, because the humidity is more on rainy days. Okay, got the activity everyone? Now that was the observation that you will be writing. What can be the conclusion? What can you conclude? So you can write that rate of evaporation depends on following factor. Firstly, you can write that rate of evaporation increases with increasing speed of air. What you will write? Rate of evaporation increases with increased speed of air. Secondly, you can write rate of evaporation increases by increasing the surface area. Okay, so if you have to, like, you might have seen your mom, if she has to like dry up a bed sheet or something which she has washed, she is going to like keep it properly. She will expand the surface of the bed sheet so that it gets dry quickly, right? So we can say, we can conclude over here that rate of evaporation increases by increasing the surface area. Okay, and lastly we can say rate of evaporation decreases with an increase in the presence of humidity in the air. So if there is more humidity, the rate of evaporation will decrease. See, it is increasing in two cases. when the surface area is increased, and the second case is when the speed of the air is increased. In that case, rate of evaporation will increase. But when it comes to decrease in rate of evaporation, in that case, if the humidity in the air is increasing, so you can say if the humidity in the air is increasing, the rate of evaporation will decrease. So I want you all to write this conclusion in your book. I hope everyone is writing the conclusion and you're writing the factors affecting the rate of evaporation. After this, we will be like discussing it in detail, but before that, I want you all to write the observation and conclusion as discussed now. After this, see, we have like you must have observed that the rate of evaporation increases with when you increase the surface area, when you increase the temperature, and when the speed of the air increases. So in that case, the temperature will increase, and it will decrease when the humidity in the air increases, right? So let's discuss in detail. So rate of evaporation increases with increase in surface area. So see, we know that evaporation is a surface phenomenon, right? So more like bigger the surface, the evaporation is going to be quicker. If the surface is smaller, the evaporation process will be slow, right? So we can conclude that evaporation is a surface phenomenon, and if the surface area is increased, rate of evaporation will increase. For example, while putting cloths for drying up, we spread them out, right? So this is the same example I gave you. Like instead of cloth, you can say blankets or anything when your mama washes them. Okay, what she does, she spreads them out very well so that it dries up quickly. So that is how we can say that rate of evaporation increases with increase in an surface area. Okay, then secondly we have that rate of evaporation increases with an increase of temperature. So when the temperature will increase, rate of evaporation increases. If there is more sunlight outside, okay, the temperature is more. what happens? The cloths dry up quickly, right? So this is the same thing you can like relate to. With the increase of temperature, more number of particles get enough kinetic energy to go into vapor state, and that is why the cloths dry up easily during summer season, because the temperature is high. Okay, then now the rate of evaporation will increase with the decrease in humidity, because we are studying when it is increasing, right? So here we will say like when humidity in the air decreases, rate of evaporation will increase. So what is humidity? First of all, humidity is amount of water vapor present in air. Okay, so the air around us cannot hold more than definite amount of water vapor at a given temperature, because if the amount of water in the air is going to be high, the rate of evaporation will decrease, and that is why it has been stated that rate of evaporation increases with decrease in humidity. The amount of water vapor in the air should be reduced, then only the rate of evaporation will increase. Otherwise, what will happen? If the amount of water vapor in the air is more, if you like keep the cloths outside, they are not going to go like dry up quickly, right? You will feel like it is getting more wet. Okay, then if the wind speed increases, in that case the rate of evaporation will increase again. So it is a common observation that cloths dry faster on a windy day. With the increase in wind speed, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. Got this 4 points, everyone? So we just discussed on factors affecting the rate of evaporation, and I want you all to please take a note of this in your book with proper example. I hope everyone is writing this. You need to write all the 4 points. That rate of evaporation is going to increase with increase in surface area, increase in temperature, increase in wind speed, and decrease in humidity. All the 4 points are important. So I want you all to please take a note of it, and if you can explain it with an activity or an example, you can explain them properly. So after this, now we are left with how does evaporation cause cooling. So I'm not going to continue this part today. We will be like studying about, today we discussed on what is evaporation and the factors affecting evaporation in detail, right? So in the next part I will start with evaporation, like how exactly evaporation cause cooling in detail. Then we have to discuss like more two different states of matter that we have, which includes plasma and Bose-Einstein condensate. Now we have already studied about solid, liquid and gas, right? So we are just left with two more states of matter, that is plasma and Bose-Einstein condensate. So I'll do that in the next part, and then we will be like discussing the summary in detail, like what exactly we have studied in the whole lesson of matter in our surrounding. So summary discussion is also very important because you come to know whether if you have any doubt in any of the lesson, if you're not getting any of the point over here, you will understand that there is some you can say doubt in that concept you have. Okay, so we'll do that summary discussion in detail, and after this summary discussion we have quantity units which have been given. We will be like going through it as well, so I'm showing you all. Please go through this once very well because like you should be knowing this. So here we have some measurable quantities along with the quantity unit and symbol which has been given. So I want you all to please go through it once. Then we have like few exercise questions to discuss in detail. I'm going to show you the questions one by one, and I want each one of you to please go through them properly because you will have to answer them also. I want you all to please go through all the questions that I'm showing on screen quickly. I hope everyone is going through the question which have been shown on screen. So I guess we have total 9 questions like this, but you should be aware of like the question so that you will be able to answer it properly in the next class. So this is the last question for the lesson matter in our surrounding. Okay, so this is how we are going to end up with the lesson matter in our surroundings. Okay, so we are just left with one small part, how evaporation causes cooling, and then we will be discussing about plasma and Bose-Einstein condensate in short, and then the exercise questions. So in the next part I'm going to complete with the whole lesson matter in our surrounding. We will be even discussing the exercise questions one by one. Okay, but you all make sure from your end that you're revising it properly, and if you have any doubt, please clear them all. And as I told you today, whatever activities have been given, you should be able to explain your observation, you should be able to give a proper explanation to your question, and even you should be able to conclude that. Okay, this is very important. So like that way you need to like make sure you're understanding the lesson, because if you don't know any like answer on, okay, if any question has been asked and you're not aware of what to write, you can like actually explain the activity over there, because activity also tells us the characteristics, right? So please make sure you're not skipping the activities, you're giving equal importance to them as well as much you give it to theory part, rectifying them. And I don't want any one of you to rectify any of the concept. You need to understand them. And evaporation process, may I give you a better example about cloths, drying of the cloths. That is one of the best example you can have. Okay, so now like I'll end this session for now, and the rest of the part which has been left, I will be continuing that in the next class. Thank you everyone.